Hello everyone. So this is a question from RE-NEET 2026. Given below are two statements. Statement 1, FeOX thrice 3 minus is chiral. Okay. Statement 2, trans CrH2O twice OX twice minus is chiral. And given that OXH2 is COOH. Okay. So we have to determine which one is correct, which one is incorrect. So the chapters involved is coordination compounds. Okay. So we should know that OXH2 is the compound oxalic acid. Okay. So OXH2 is the compound oxalic acid and it has the formula COOH connected to another COOH. Okay. Now coming to statement 1, which says that FeOX thrice 3 minus is chiral. Okay. So here OX is the ligand and it is actually oxalate ion. Okay. You can also write oxalate ion as COO minus connected to another COO minus, or in detail you can write C double bond O single bond oxygen 1 2 3 4 5 6 electrons negative charge. This carbon connected to one more carbon, double bond O single bond 1 2 3 4 5 6 and a negative charge. Okay, so our oxalate ion is this guy in detail, where you can see all the bonds, this guy. Okay, so ligand is it donates electron to the metal atom or ion and form a coordinate bond. So ligands donates electron to metal atom or ion and form a coordinate bond. Okay, so one more information that is important is that oxalate ion or OX is a didentate or bidentate ligand. Important. Didentate or bidentate ligand. Okay, so a didentate or a bidentate ligand has two donor atoms which allow them to bind to a central metal atom or ion at 2 points. Okay, very important. So a bidentate or a didentate ligand has two donor atoms which allow them to bind to a central metal atom or ion at 2 points. Okay, that is, with respect to diagram, I can show it to you. COO minus, COO minus. So you can see it has two donor atoms, oxygen and oxygen, which binds to the central metal atom or the ion at 2 points. This is one coordinate bond, this is the other coordinate bond that it forms. Okay, so therefore the coordination number So what is coordination number? It is the total number of coordinate bonds formed with the central metal atom or ion by the ligands. Okay, so coordination number is the total number of coordinate bonds formed with the central metal atom or ion by the ligands. Okay, so therefore the coordination number of Fe in the complex, that is FeOX thrice 3 minus. Okay, so the coordination number of Fe in this particular complex is 6. Okay, is 6. Okay, because OX, or C2O4 2 minus oxalate ion, is a didentate ligand. Okay, and there are 3 of them in total. So therefore, and we know that a didentate forms two coordinate bonds. So there are three of them. So the total number of coordinate bonds is 3 into 2, which is 6. So 1 OX or C2O42 minus forms two coordinate bonds. Therefore, three of them will form 6 coordinate bonds. Therefore, the coordination number is 6. Okay. And when the coordination number is 6, the complexes are octahedral. Very important. When coordination number is 6, complexes are octahedral. Okay. So therefore, FeOX thrice 3 minus this guy is octahedral, and it will look something like this. Okay. So if I draw its structure, Fe, okay. So this is what it will look like. And this is above the plane of screen, and this is below the plane of screen. Okay. And the molecules or ions which are non-superimposable mirror image of each other are called chiral, and this property is called chirality. Okay, very important. Molecules or ions which are non-superimposable mirror images of each other, so they are called chiral or optically active, and this property is called chirality. Okay. To check the chirality of FeOX thrice 3 minus, we have to draw its mirror image. Okay. So the mirror image of this guy, so let's say this is my mirror. Okay. So it will look something like this. Okay. So this is the dextro form. It has to be determined experimentally, but let's assume that this is the dextro form. So this will be the levo form. Okay. So clearly the dextro and the levo, so dextro form and the levo form. So clearly the dextro and the levo forms are non-superimposable mirror image of each other. Okay. That is, the object and its reflection cannot perfectly align or overlap. So they are not the same thing. Okay. That is, if I take this guy and place it here, they won't overlap or align, okay, perfectly. So best example to understand is, you can see our left hand and the right hand. Okay. So therefore, FeOX thrice 3 minus is chiral because it forms non-superimposable mirror images. Okay. And therefore statement 1 is correct. Okay. Remember, for exams, whenever you see MAA3 type complexes, okay, where M is the central metal atom or the ion, and AA is the symmetrical didentate ligand. Very important. Symmetrical didentate ligand, for example, oxalate ion. Okay. So whenever you have MAA3 type, they are always chiral. Okay. Now coming to statement 2. So statement 2 says that trans Cr H2O twice OX twice minus is chiral. Okay, so we should know that H2O is a unidentate ligand, which means it will form one coordinate bond with the central metal atom or the ion. Okay, therefore the coordination number of Cr is 6. In this particular complex it is 6. Okay, so how is it 6? There are two oxalate ion, so which will form total 4 coordinate bonds. Okay, 2 OX form 4 coordinate bonds because it is didentate, and 2H2O will form 2 coordinate bonds. So therefore in total there are 6 coordinate bonds. So therefore this complex is also octahedral. Okay, and so this is also octahedral, but this is trans. Okay, in trans, make sure that similar groups are on opposite position, very important. So in trans, similar groups are on opposite position. Okay, so therefore to draw this guy, I will keep one H2O above the screen and one H2O below the screen. Okay, so therefore trans CrH2O twice OX twice minus will look something like this. So I will have chromium, one H2O above the plane of screen, one H2O below the plane of screen, OX OX. Okay, and it has a charge of -1. Okay, so this is my trans CrH2O twice OX twice minus. Okay, to check the chirality of this guy, let's draw its mirror image. That is, so its mirror image will look something like this. So we will have chromium, H2O above the plane of screen, H2O below the plane of screen, and two oxalate ions. Okay, and obviously it will also have charge of -1. Okay, so clearly trans CrH2O twice OX twice minus is achiral or optically inactive. Okay, so this guy is optically inactive, or you can say it is achiral. Okay, that is because it forms superimposable mirror images. That is, this guy. So let's say this is our object, and let's say this is the reflection of the object in the mirror. Okay, so the object and the reflection perfectly overlap or align. They are the same thing. Okay, so therefore they are achiral or optically inactive. So you cannot say that this is, these two are different thing. One of them is dextro, one of them is levo. So you cannot say that they are not optically active. They are achiral. So therefore, so I will write it down that it forms, these two are, and say they form superimposable mirror images of each other. That is, object and its reflection perfectly align or overlap. Okay, so remember for exams, whenever you see trans MAA2 B2 type complexes, they are chiral. Okay, where AA is, sorry, they are achiral or optically inactive. So this AA is a symmetrical didentate ligand, for example, oxalate ion. Okay. Be careful, the cis form of MAA2B2 will be optically active or chiral. Okay. So therefore, the statement 2, which says that trans CrH2O twice OX twice minus is chiral, is incorrect. Statement 2 is incorrect. Therefore, the final answer is going to be statement 1 correct, statement 2 incorrect. Okay. Thank you.